In this video we're going to take a look at integration by parts problem, but instead of using the traditional formula we're going to try this table method, but we're still going to have to start off by choosing what is U, and then we're also going to look at choosing what our dV is. So in this problem we're going to start off with our U as x to the fourth, and a little bit of thought about that is you always want to pick the u value that is going to decrement when you take the derivative. So over here in the left column we're going to put our u, which is x to the fourth, and we'll put that on the first line over here. And in this column, the left column, we're going to take the derivative, and over in the right hand column we're going to take the integral. So if u is equal to x to the fourth, that means that our dv is going to be what's left in the problem, which is e to the x over 2 and dx. Well, that's got to be a bad looking e, so let's try that again. So we have e to the x over 2 power dx. So basically what we're going to do is we're going to keep these lined up, and over here we're going to have e to the x over 2, and we're going to just take the integral of this. But we're going to start off by taking the derivative of x to the fourth, and let's just keep taking the derivative until we run out of derivatives here. So you have 4x to the third. You take the derivative of that again, you're going to get 12x squared. Take the derivative of that, you're going to get 24x. Take the derivative of that, you get 24. Take the derivative of a constant, you're going to get 0. So can't take the derivative anymore, so we're going to go ahead and now take the integral, and we'll switch colors. We'll do this one in orange. So the integral of e to the x over 2 is e to the x over 2. We need a 1/2 out in front of there, right, to take the integral. So if we think about doing the u substitution, we'd have to multiply it by 2 over 2, and the 1/2 would cancel out, and we end up with 2e to the x over 2. You take the integral of that. The integral of e is e to the x over 2. You already had your 2 out in front of there. You multiply by another 2 and you get 4. And then you see the pattern here, so it's just going to go 8 e to the x over 2. And let me remind you that on this problem we do need to match these up, right? So in other words, if you're making a table, you want to keep these lined up so that you don't make a mistake in the next step here. The integral of that is going to be 16 e to the x over 2, and do it one more time, and we get 32 e to the x over 2. Alright, so now this technique here is to draw diagonals. Let's see, pick a different color here. We'll pick blue, and you're going to be multiplying these two entries together. You're going to multiply these two entries together, so on and so forth. And then finally we have one more right here. Okay, and then the third column over here that sometimes is overlooked is the sign, what you assign, the positive or negative sign. You start off with positive and you just alternate your signs. Plus, looks like we have one more column here to do, which is going to be right here, and that would be a negative.
How you doing, Greg?
Good. So now that we've assigned all the appropriate signs over here, we can just follow our table and assemble the integral. So here, the integral would equal 2 times e to the half. Well, actually, let's write it in the same order that we came with. So you would have 2 x to the fourth e to the x over 2. That's positive. And then the next one's going to be a negative 16, because you're multiplying your 4 times your 4 here. And you have negative 16 x to the third e to the x over 2. Okay, and then we have 12 times 8, which would give us 96 x squared. 96 x squared e to the x over 2. And then after 96, we would end up with negative 384. I did these earlier. Of course, these numbers are going to get kind of large. Negative 384 x to the first power, and an e to the x over 2 again. And then the last one becomes very large. I'll write it right underneath here. We have plus 768, and it's e to the x over 2. So this will save you from having to do the integration by parts multiple times when you have a large problem like this. Okay, we'll see you in the next video.